Hello friends, if you have find this video and channel interesting which will add value to your knowledge and learning, then please like it, subscribe my channel and also click on the bell icon so as to get the automatic notification of latest uploaded videos. Thank you. Let's see what this question is asking about. This question is for CCNA routing and switching. How do TCP and UDP differ in the way that they establish a connection between two endpoints. We have four options. Option A, TCP uses the three-way handshake and UDP does not guarantee message delivery. Option B, TCP uses synchronization packets and UDP uses acknowledgement packets. Option C, UDP provides reliable message transfer and TCP is a connectionless protocol. Option D, UDP uses SYN acknowledgement and FIN bits in the frame header, while TCP uses SYN acknowledgement and acknowledgement bits. Let's see. I have explained a bit about TCP and UDP. What are the messages involved in TCP and UDP when they try to communicate between two endpoints, and what are the differences between TCP and UDP. So here I have explained about the TCP states and messages. Okay. So actually TCP is a three-way handshake mechanism. Means it works in a three-way handshake mechanism. How it is? This is the client state and this is the server state. So first client send the SYN message, SYN. SYN stands for synchronization message. Once it sent the synchronization message, the server then acknowledge its back to the client, that is with the SYN ACK. So SYN ACK is the synchronization and ACK is the acknowledgement message. ACK stands for acknowledgement message. Okay. Once the SYN ACK message received by the client, it again establishes the session and sent back the ACK message. ACK stands for acknowledgement message. So TCP is basically works on the three-way handshake mechanism. One is SYN ACK and ACK. Okay. Now let's see the difference between TCP and UDP. So here if you see TCP versus UDP. Okay. What is the difference between TCP and the UDP? Okay. And both TCP and UDP works on the OSI transport layer, which is the fourth layer of the OSI. Okay, it is a transport layer protocol. Okay, so TCP, which is the transmission control protocol, is a connection oriented protocol, whereas UDP is a connection-less protocol. Okay, and if you see, TCP is works on the three-way handshake mechanism, which we already seen: SYN ACK, and ACK. And in UDP, there is no handshake mechanism, but it works on the query and response. It broadcast and multicast. Okay. TCP has a stateful connection and UDP has a stateless connection. TCP is secure, UDP is unsecure. TCP is slow. Why it is slow? Because it's a connection oriented protocol, or works on the connection oriented mechanism. That's why it is slow. And UDP is fast because it's work on the connectionless mechanism. Okay. TCP has flow control. UDP does not have any flow control. TCP does advanced error checking. UDP does the basic error checking, which is the checksum. TCP works on the acknowledgement mechanism, where in UDP there is no acknowledgement. TCP has large overhead which is around 20 bytes header. UDP has a small overhead which is around 8 bytes header. TCP is used by critical applications, okay, where the acknowledgement is necessary, and UDP is used by real-time applications where time matters, okay. TCP guaranteed the transmission. In UDP, there is no guarantee of the transmission. In TCP, packet reorder mechanism is there, but in UDP, there is no reorder mechanism is there. Means if the packet is lost, means it's lost. And it support DNS, HTTPS, FTP, SMTP, and similar in case of UDP, it support DNS, HTTPS, FTP, SMTP, etc. So the correct answer following our explanation 1 and 2, option A looks to be a correct answer for this. TCP uses three-way handshake and UDP does not guarantee message delivery because it's a connection less protocol. Option A is the correct answer for this question.